Good. So, good. Very well. So it's 13:36 for me, and we can start. And I hope everyone has joined us already. So we can start that. So, welcome to the KubeCon 2020 virtual. This year wasn't easy for all of us, and we have a lot of issues. But finally, we are here together, and virtual or not, well, you know, KubeCon this year should have been in Amsterdam, and I love Amsterdam. It's a great city, and I have some friends there. But okay, it's better to collect that together, and no one has to travel. So we may have people from all over the world. And that's amazing. So, good to be here. Hello, everyone. Hello, Bettina. And we can start. Oops. So, things we are going to work on with today. Those are Cassandra, Kubernetes, operators, Cassandra operator, and some of the monitoring. So, that's Apache Cassandra with Kubernetes. And I know, and our crew knows, what Cassandra is a perfect fit for the distributed systems which you usually manage with Kubernetes. In the end of this workshop, you will know why. And things we are going to do today, we have to prepare something because it's a hands-on workshop, so you are going to do some job. Then, we are going to discuss some things about the Cassandra. We are going to talk about Kubernetes operators and Cassandra Kubernetes operator to be more exact, and we will see how easy it to organize the monitoring for the data with metrics collector for DataStax Enterprise and Apache Cassandra. But well, today is about Apache Cassandra, so we are speaking about the open source technologies. And very important notice, that's a KubeCon, so we expect you to have at least basic understanding of a Docker and Kubernetes, so we will not spend time explaining what's the container, what's the image, and what's a pod. If it feels like you don't fit this requirement occasionally, well, what I can tell, then you have a recording of this workshop and you can get back to us, watch us today, and watch on this later when catch up with some requirements and prerequisites. Then next, today we are going to work in the multiple windows and we are going to jump from one to another. First, streams. So we have this presentation at YouTube and Zoom. Zoom is the main for us. And well, YouTube is a second. We actually should be streaming right now and Twitch as well, but that's a plan C if both Zoom and YouTube doesn't work for you. So you see we have some replication and fault tolerance took seriously. Then runtime. So that's a hands-on workshop and you are going to do the exercises therefore. And there are two ways to do the exercises on your machine or on our cloud box in the cloud, with help of the AWS. And if you are not so much into them, I will explain it in a moment, don't worry. Then for questions we can use Zoom chat and YouTube chat, and there are very skilled people to answer your questions, but questions in Zoom chat, questions in YouTube chat will disappear after a workshop. And if you want to stay tuned with us, if you want to stay connected, please use Discord. I kindly ask one of our people to have everything, all the links connected. And well, this thing is delivered smoothly. I explained it in the next slide. So we prefer to chat at Discord. Link should be in the chat. I thank my great teammates for sharing this thing. Then materials. slides, notebooks, all the files are in the GitHub, DataStax Academy, KubeCon, Cassandra workshop. You will see it in a moment as well. Now, about the things you are going to do for the exercises, laptop or cloud instance. If you have a Docker-enabled machine powerful enough, like 4 cores, 8 GB of RAM, Docker installed, you can do it completely on your own. And there is a good thing, you work with your own environment, you understand how it works, and so on and so forth, so you are cool. If it goes not so easy for you and you want to hide it anyhow, if it's a problem for you, then we deliver a special node in the cloud, so you can just switch and use this cloud instance. If you have registered at the KubeCon 2020, datastaxtraining.com, then you must have received an email already. And if you registered and you didn't receive an email, please check your spam folder, because we are dispatching a lot of those nodes, so my email could have been delivered to spam folder. Please check. If you don't, and well, this form is closed already, then please contact jack.fryer@datastax.com by email and ask for the training node. Good. So, we are good to go. Let's proceed. And first of all, we are going to ask you some questions. Menti is the tool which allows us to ask you questions and see your answers all together in the graph, like showing fancy things. And I kindly ask you to go to menti.com, use the code 5163695. I repeat, 5163695, and then we can go and I will ask you questions. Yes. Okay, I see a lot of people are joining. If you have been at one of our DataStax workshops before, you know we use Menti all the time, because it's the easiest way to communicate with so many people at once and see what's interesting for you, which topics you know and which topics you maybe not so experienced, so we can develop more in this field. And that helps me to know how much time I should spend on each time of the topic, so we will cover more and more things. Good. So code for menti.com is 5163695. It's directly on the screen. It should be, it should be there above on the screen. Good. And the easiest way to go with Menti is simply open menti.com in your mobile phone and in the browser, and we can start. Okay, more and more people join it. Let's start. And while we are speaking about the Menti, we will play some prizes later. So, first question, do you have experience with Docker? Known but never use it, use every day in production, use regularly for dev, use it 1 or 2. Good. So this is just a question, but later we will run a quiz, 2 parts of a quiz, and 3 people who will take the highest places, the biggest amounts of points, they will have some special prizes from us. Good, so I see, so that's a KubeCon and very obvious. Use every day in production, use regularly for dev, use it 1 or 2. Okay, let's move on then. Next question, how much experience with Kubernetes? I guess you're all interested in Kubernetes, but how much and how much you are using that, that's fine. Kubernetes expert. Okay, we have some well-experienced people there. Use regularly. Use it 1 or 2. Known but never use it. That's fine, as long as you can understand what's the situation with Kubernetes and how it works, then it's good. Well. A lot of people there already, so let's move on. How much experience with Apache Cassandra? And now, that's another thing. Because this is a KubeCon, not a ApacheCon or CassandraCon, so it's very fine. If you never used that, we will explain how it works and why it's so good fit for Kubernetes, and well, why we say it's a cloud-native database. Okay, no idea. Is it a database? Yes, it's a database. It's a great database. Have heard but never use it. Most of the people. Basic understanding and or experience. And we have small amount of experts, but we have some, which is great. Okay, next one, and I will go now very quick. Prometheus. Do you have any ideas of Prometheus and how it works and why people use that? Daily usage. Wow. Know how it works. Perfect. Something about monitoring, never use it. Okay, I will say a couple of words about it, but nothing so much because, well, it looks like you are good in it already, more or less. We will not do a deep dive in Prometheus, but we're definitely going to cover a couple of things with that. And Grafana. Last question about the technology, so I will know how deep I should go with every of the steps. I know how it works. Grafana expert. Never heard of it. I know it, but I never use. You know what? At the workshops and the conferences, it's always like that. At the same very moment of time, you have people who never have heard of a technology, and you have some core team directly in the same room, virtual room in this case. So we have noticed more or less similar amount of Grafana experts and people who never heard of it. Okay, that's fine. That's why we love conferences. Next one. We are almost done, so final questions. What's your operating system? Choose all you are using for, well, job-related things. And you see, at the most of our workshops, we usually get the answer, Windows, all the time. At the KubeCon is, boom, Linux. Yeah, that's what I like. And the similar amount of OS X and Windows. Seriously, that's incredible. At a lot of workshops, we do a lot of different workshops about different technologies. And, well, that's incredible. That's the first time I see a result so overwhelming for Linux. Perfect. Then, operations or development? Or both, maybe. I guess I know the answer. Yes, the correct answer is I wear all the hats, because that's the KubeCon. Perfect. So, yeah, that's a clear win for all the hats. Okay, so, but don't worry, we have content important enough for all of the fields, let's say. So if you are pure operations or pure development person, that's very fine as well. We will not anyhow segregate you or something. Let's go next one. And last one. Do you prefer to do the exercises at your laptop or with the cloud instance? In general, we recommend to use your own or your laptop or your whatever you use, because cloud instances, you see, there is a lot of people here, and AWS makes us no gifts, so data stack space for all the cloud instances we are running, and that's as we are loading them hard. Those are pretty expensive nodes, so we cannot let them run for too long. So in general, we recommend to stick to your environment. If it doesn't work, then switch to cloud training instance. Good. So we are done with the questions, and let us move back to the slides. Now, Cassandra basics. So, data. We have so many applications, and applications, especially stateless applications, run perfectly with containers, with Kubernetes, with whatever. It's easy. But things aren't getting so easy when you start to handle data. And you know what? By some years already, by many analyses and researches, it's predicted to be overall amount of digital data in the world overall more than 175 zettabytes in just 5 years. So, or maybe even more, or more close to 200 zettabytes. And 200 zettabytes, that's a lot, like seriously, very a lot. So, what do you think of that? Cassandra is getting more and more important in the field of storing data because it was designed to work under 3 very serious circumstances to cover very 3 important checkboxes, points. First one, any amounts of data. You have 1 kilobyte of data or you have dozens petabytes of data, Cassandra should be able to handle that. First point. Second point, Cassandra should be able to dispatch these amounts of data within milliseconds, with no blocks, with no, oh, now I have to wait for join, and so on. And last point, Cassandra must be geographically distributed. So you want to have it in any data center of any part of the world, maybe later on Mars or Moon, and it should be active all the time. So let's see how it works. First, so Apache Cassandra is a NoSQL distributed database, and every word here is very important. You can install Cassandra on a single node. Well, it will work, but that's not where you see all the power of a Cassandra. One installation, one single node is usually about 1 terabyte of capacity, but it depends on your strategy. Some companies prefer to have less, some companies prefer to have higher density. It's possible. And that's approximately 3,000 transactions per second per core, but actually higher by now. And that's not the way to run Cassandra, because usually we speak about multiple nodes. And every node communicates with every node via gossiping. So nodes together, united in the ring, which makes a data center. And the cluster can consist of multiple data centers. So single cluster can be completely all over the world. And every node is able to communicate with everyone. And there is no master, no slave. Every node is able to perform all the same duties. They are responsible for different pieces of data, but they work together and every node is able to answer your request. Cassandra is distributed, and replicated. Your record is here, but also your record is here. And we have usually replication factor 3, I explain it in a moment, so your record is here as well. But also here, because you may have multiple data centers within the same cluster. So, the main features you have to remember, it's distributed, and every node is able to process your query. It's replicated, so every piece of data is replicated to multiple nodes, which makes it available. If one node is fail, if even the data center is fail, but your Cassandra cluster is configured properly, you will get your data back. And it's masterless. It has no single point of failure. If your data is completely not available at the moment, it mostly probably means your client has no connection with the internet, or you have single data center and only one data center, and well, this data center isn't available. So nodes are organized in a ring. Nodes monitor each other's health all the time using a gossip protocol. And Cassandra routes requests away from the nodes that are down or slow. So every node is smart, every node understands the situation in the cluster, who is alive, who is dead, who we should ask or who may be overloaded, and therefore routes the roads accordingly. One of the best features of Cassandra I really like is the tendency to use horizontal scaling. So, 2 words about the scaling. There are, we usually say, 2 kinds of scaling: horizontal and vertical. Vertical scaling is where you had like middle range server. Now you want to have something bigger, so you buy one more new expensive server, migrate your data, decommission your previous less powerful server. Vertical scaling works well, but it has 2 problems. First, it becomes very expensive very soon. And second, it still has the same issue. Small amount of expensive nodes means you need to lose less amount of nodes before you really fail to dispatch the data. So Cassandra goes with horizontal scaling. Horizontal scaling offers you to use multiple less expensive hardware just have more of them. On the example on the left, we see 3 nodes ring, 3 nodes cluster, let's simplify, and it's able altogether to dispatch 100,000 transactions per second. So we can approximately calculate the power of every of the nodes. But Cassandra has very low to zero overhead to adding new nodes. And when you add a new node, like in this middle example, we have 6 nodes, you literally multiply your transactions per second by 2 because you just increase the amounts of nodes by 2. And the more it comes, the better it works. So, scales linearly. There were a great research done by Netflix. Netflix is one of the biggest users of Cassandra. By the way, one of the biggest deployments of Cassandra in the world belongs to Netflix. It was around 70,000 nodes or something, 70,000 of servers, Cassandra nodes. And every time you add the next node, you just add some more firepower without any overhead. Need more capacity, need more throughput, add more nodes. Very simple. Then, data is distributed, we say. How does that work? Then you work with a table, and well, we have tables because Cassandra is NoSQL but not tableless, so your data is structured into the tables. There is a special field or column, or maybe multiple columns depending on your architecture. Those which works as a partition value, or so-called partition key. And what's when we have in this table username, city, phone number. And in this case, city is going to be the partition key. So when we start to spread this table, it goes like this. And every node is responsible for a partition. Now there is a question. Why? Why do we need that? Why do we spread the data this way? Answer is very simple. Remember the point 1. Partition, Cassandra is ready to work with any amounts of data. And what is a big data? There are many definitions of a big data, but I like one, the very simple one. Big data is the data which doesn't fit on the single server. So we go here with a simple point. We spread the data. It's kind of similar to sharding, but sharding in relational databases, for example, it's a painful process. And we don't want it to be painful, so we don't want to use sharding. Partitioning is much more native process, organized and managed by the cluster by itself, so you don't have to worry about the data migrations over nodes. You add more nodes, Cassandra will handle the distribution of the partitions in this cluster, and that's great. So, data is distributed, but also data is replicated. So we want our data to be available always, even if a single server is down. And when we have data is distributed and data is replicated. So every partition is stored multiple times on the amount of servers you specify when you create the Cassandra key space, the storage for the tables. And last point, as I say, data is distributed everywhere. Geographic distribution. It means you may have multiple data centers over the world. They all are active, sharing the data with each other. You are flying from Europe to the United States. You are taking Uber to get to the airport. You are taking Uber to get from the airport. Mostly probably this operation was processed with DataStax Enterprise or like an enterprise version of Apache Cassandra. And that's still the same database and table, but with different data centers and locations. But also, Cassandra is platform agnostic, so you can run it nearly everywhere. And that's very good for hybrid clouds and multi-clouds, Microsoft Azure, AWS, Google Compute Platform, Google Kubernetes Engine. That's all very, very fine. And then, of course, on premises. And all of that's the same time. You literally can have one ring in each cloud provider in the world, and then you can have it all working together and storing the same data. Of course, it may lead to some pretty serious payments because of data transfer between the clouds. If you work with a lot of data, it may make a problem, but well, it very depends on your strategy and what do you want to have. If you are running for a real disaster tolerance, not only fault tolerance, that's a hybrid cloud, and multi-cloud is a good way to go. So, how the ring works, how the data is distributed. First, remember we have a special column or multiple columns, which is a partition. So in this case, there is a country, and country, for this table, every node will receive a partition based on the country, so we will have multiple cities of the same country per node. How the ring works? So we receive first partition, second partition, and so on and so forth. Every node is responsible for the partition. And when we ask for some data, first, any node is a coordinator node. People start to mix coordinator node as a master node, which is wrong. Every node can process any request, and that moment it happens, it becomes a coordinator node. So, coordinator node receives some data and calculates the amount of, calculates the partition hash. So we take this value, like in the last example, it was a country name, like United Kingdom or France. We calculate the hash, and every node is responsible for the range of these hashed values, and therefore this data goes, for example, to the node down here, which is called a replica node. Every node is responsible for the range of tokens. This mechanism called this is a hashing mechanism called murmur-free. That's not only about Cassandra, but also about Kubernetes, so I have to move on. If you want to get really deeper with Cassandra, I ask you to join our next workshop regarding only Cassandra, so we will have more time to work on that. So, replica node gets the data, but we want to have some more. That's a replication factor 1. RF means 1. And what does that mean? Every partition will be stored only once. And that's bad for us. At the moment when you lose a server, part of your data will be not available. So we go higher. Instead of replication factor 1, we start to use maybe replication factor 2. And then the data will be stored to multiple nodes, to 2 nodes with replication factor 2. But recommended value is replication factor 3. So we go, and every partition is stored 3 times, every piece of data stored 3 times. And it may look like a little bit of redundancy, but you know what? Disk space is cheap. So I don't care so much about the disk space. What I care is my application to be available all the time. Well, so node failure. That node is not available anymore, but we still have more replica nodes. When replica nodes will receive the data, a new mutation, no update or insert, and that's good, but we have one node is down. What happens then? So, when some node has more up-to-date information than another replica node, that's bad, that's called inconsistency. And Cassandra has really a lot of self-defense mechanisms to protect itself from inconsistency. In this case, first layer of the defense, first row of the defense, is mechanism called hinted handoffs. As soon as one of the nodes didn't confirm it for what it's got the data, coordinator node stores the hint. And as soon as node recovers, and due to gossiping, coordinator will get news about that. Hey, I'm node 83, I got back. It dispatched the hinted handoffs, node loads the lost information, and it's consistent again. And there are a lot of self-defense mechanisms. Self-healing from the inconsistency. So we just seen hinted handoffs. But there are also repair on read, scheduled repairs, incremental repairs, and many others. That's more about operations with Cassandra. There is a lot of things to do. So, but also we have multi-data center replication. And we have in this example data center west and data center east. So, how it works? Then your application starts. You want your application instance in the United States work with the database in the United States. And your application instance in Siberia to work with a data center in Siberia, not vice versa. So every day, every application running has an idea of a so-called local data center. What is the local data center? Local data center is a data center which is the closest to this instance of application. So if you have one, let's say, instance of a data center and database in Frankfurt, and you run your application or on AWS in Europe, Central One, therefore that will be a local data center for your application. And we have this application working with Data Center West. It delivers information to Data Center West, and coordinator node delivers information to replica nodes within Data Center West, and also delivers information, one message, not 3, not 5, only 1, to the remote coordinator node, which is any of them. So any node is a coordinator node. Don't forget, no masters. And then remote coordinator node is responsible for delivering information to all the other nodes. And now, I bet some of you already have the question. Okay, we have data replication. That's great. But it also brings a problem. Tell me. That's the situation when we have case with when one of the nodes didn't get your message. One of the nodes somehow missed the data. It was down. There were network partitioning. Something went wrong. You know, like that's real life. Shit will happen. It's just the law. It will happen again and again. So how do we handle that? Very easy. There is a built-in mechanism, your very big helper, called it consistency levels. Oops. Very well. So what's the consistency level? Think of one idea. The same application may work with very different kinds of data. So it may be application working with some money, like WeChat. It may have some profile pictures, logs, and also credentials and financial data, any banking operations, and so on. Like very many applications like that, I don't know, PayPal. And it works with money, and you don't want your money to be not consistent, but also it works with, I don't know, user profiles, user photos, and you don't care so much if the profile picture of your friend was updated, but you are opening his or her profile and you see an old picture which has been changed half second ago. Is it a big deal? No, no one worries about that too much. So when working with data using Cassandra, you know your data at best. No one knows your data better than you. And then you specify, for this query, I work with highly important financial data or something like very important, and I want to have high consistency level, and I will better wait for a second. Well, not for a second, but I will better wait for a moment, but get the consistent data. And this one is like secondary data, so I just want to dispatch it as fast as possible, and I don't want to have it, any longer. So, consistency level, how it works. With the consistency level 1 and replication factor 3, your client will wait for only one confirmation out of 3 replica nodes. The write queries are done asynchronously. All the nodes receive it more or less in the same moment, depending on your network state. But then, as soon as you get the data, that's very fine. You have one confirmation, consistency level 1. Okay, I'm good. Client receives the answer. We are done. Then, so it works. It's potentially the fastest one because you don't wait. You wait for confirmation from only one node. But there is another thing. There is a consistency level quorum, and that's much more interesting. In this case, as you could guess, client and coordinator node waits for the confirmation of the majority of the nodes. And that's why we recommend to use replication factor 3 or 5. So majority will be 2 or 3. When it's easier, so you can afford losing a node and consistency level quorum still reached. And then we wait for the confirmation. In this case, as we have replication factor 3, majority will be 2. We got 2 confirmations and we are good. Then, consistency level all. It looks good so far, but let me tell you a thing. With consistency level all, you will wait for all the confirmations from all the replica nodes. And what happens if you have network partition between some of the nodes, or one of the nodes is not available? Coordinator node after the timeout will say cannot reach the desired consistency level. Exception. Boom. You don't have any data. So your data is there, your data is available by itself, but you set the consistency level all, and therefore you don't have your data anymore. You cannot receive that. It's stored there. So, if you have heard of the CAP theorem or Mark Brewer theorem, in the complex network distributed applications, you cannot be highly available, partition tolerant, and fully consistent at the same time. Any network issue and you immediately has to decide. And there comes the problem. Question maybe, like, okay, I understand, but I want my data to be always consistent. How do we reach this point? I want my data to be consistent. And there is the answer. There is a way to reach that without using consistency level all. So, consistency level, consistency across the data centers, just a couple of words. Because, well, you have consistency level local quorum, and you have consistency level each quorum, so you can specify how many of your data centers must confirm your application, must confirm your data request. But let me get to the stronger consistency. Yes, so there is a thing better than full consistency, call it immediate consistency. And immediate consistency works in a very interesting way. So take a look. In the one way, to get the immediate consistency, you write with a consistency level all and read with a consistency level 1. And it works perfectly because on the right moment, all the nodes were updated or not updated altogether, and you have this exception. And then you can read from any of them, but we're still in the same trap. If the write fails, we can't write the data even if majority of the nodes is available. So the better way is the writing consistency level quorum. And one of the nodes may, at least 2 nodes will get the confirmation. I mean replication factor 3, so we have 3 replica nodes. Quorum insists what you have 2 confirmations. And then, if you read with the consistency level quorum, and you ask the proper nodes which has the information, and you accept the latest, most up-to-date value from them, when you are fine, and you get the most up-to-date value. But if it happens, you ask 2 nodes, which one of them was not updated by any reason, then Cassandra coordinator sees there is an inconsistency between the dates, returns you the updated value, and then initiates repair on read. So that happens completely in background, doesn't touch any of the developers, but Cassandra is self-recovered out of the inconsistency state. And in this case, you still can afford losing 1 node any moment, or maybe even 2 nodes if you have replication factor 5, but we recommend usually to stick to 3 per data center. And you have all your data recovered and available all the time with consistency level quorum. And there is if you are using consistency level quorum, which is a default value, you are going to have the most up-to-date data all the time. And so consistency trade-offs we have to remember. The higher the consistency, the less chance you may get stale data. But there is a possible latency. Notice the word possible. If your network is perfect, all the nodes work perfect, there is no issues, then there is will be nearly no difference between 1 and all, because, well, they all respond in the same time and network works perfectly. But we live in the real world, so no unicorns, no magic, I'm very sorry. And then, well, you may better go with the quorum. In general, the rule of the consistency and this immediate consistency, very simple. Your write replication factor, your write consistency level plus your read consistency level must be higher than your replication factor. Then you are immediately consistent. What does that mean? You have replication factor 3, so 3 nodes. You write with a consistency level quorum. Quorum of 3 is 2. You read with a consistency level quorum. So again 2. 2 plus 2 makes 4. 4 is bigger than 3. You got the immediate consistency. Another way, write with consistency level all, read with consistency level 1. So 3 plus 1 makes 4. 4 is bigger than 3. And then how to run into the possible inconsistency state. Write consistency level 1, read consistency level 1, 1 plus 1 equals 2, 2 is smaller than 3, you are smaller than your replication factor, then you may run into the inconsistency situation, although in general that's usually a rare situation. So quorum to quorum, that's a default setting and we recommend to stick to that, but there could be some special use cases. Good. So finally, and that's going to be the last Cassandra slide and we can proceed with Kubernetes. It's the KubeCon after all, so let's go closer to the cloud databases deployments. So use cases for you to understand. Any case when you have to work with the highest scalability, when today you have 1 petabyte and tomorrow you have 1000 petabytes. That's anything what relates to high throughput or high value volume or both. Heavy writes, heavy reads. Event streaming, Internet of Things, log analytics, and many others. It all works perfectly. Then, availability. So we have anything what relates to mission critical, data available all the time, data never lost. That's a typical use case for the Cassandra. And there are a lot of use cases. Well, you better know your use cases and your situation. Any kind you think of a mission critical, that can be a good choice for Cassandra. Then distributed. First, global presence, then and workload mobility, and you can distribute your workloads and database data stored all over the world where exactly you want to have it. But also compliance and GDPR. So that's a KubeCon Europe. It was supposed to be a KubeCon Europe. So now you know where, so it means what you know something about the GDPRs and compliance and so on. Cassandra allows you to set up the key space to be stored in particular data centers out of all your full cluster. And that really helps, so you can define where to store your data. And there are many use cases for that as well. And well, cloud native, it's a KubeCon, correct? So we speak about any modern cloud applications. Cassandra is a very good fit for hybrid cloud, multi-cloud, any kind of cloud, and platform agnostic, so run it everywhere at the same time if you want. And final thing we are going to do today is we are going to deploy Cassandra on the Kubernetes cluster. So let's proceed and do some hands-on work. And all the data is stored at the DataStax Academy KubeCon Cassandra workshop. And first thing we have to do is to prepare for the exercises. So what I need to go to my KubeCon Cassandra workshop. Oh, it's here already. Perfect. And what we have here, there is a README explaining all the things, all the possible materials you have. And now we do this step. I will make it a little bit bigger, so hopefully you can see that. Yes. So, two situations, two builds. If you are using your own computer, please check the requirements and install the missing tools as explained here. I will show you. Oh, thank you, Eric. I see Eric posted the materials link. Perfect. So there is a README file, and we will need following things. We will need Docker, I will not explain you how to install Docker. I trust you. We will need Docker Compose. We will need kubectl, and you, I guess, know already what's that. We may need watch just for better visibility. It's not a real requirement, so you can survive without watch, but again, Linux is the winner, so we know how to install watch on Linux. Just echo Linux rocks. And final thing we will need is a kind. Kind is a really cool thing. Kind, it's so-called Kubernetes in Docker. It allows you to have multiple worker Kubernetes installation in your own laptop. And that's really cool because you see we are going to have multiple workers, and well, we have Minikube, but Minikube is very limited at this scale, and with Kind we may have multiple things to deliver it together. If you have a real Kubernetes cluster across multiple nodes, you can absolutely use that. So that's very fine. If you have a real cluster, then you can skip the Kind step. And after the installation of the Kind, I believe you have our dependencies more or less with you, so we will need Kind. And we may get Kind get clusters. So we want to create Kind cluster, and there is a Kind create cluster, and there is a configuration file. So you may want to clone this repo. Again, that's github.com, DataStax Academy, KubeCon, Cassandra workshop. KubeCon-Cassandra-workshop, and here you have all the configuration files you may need. And here we go, Kind create cluster, Kind Cassandra config. Notice I'm speaking about your own installation because our cloud training instances already have Kind installed. And after that, the only thing you have to do is to kubectl cluster info -- context Kind Cassandra. And you have your kubectl configured to work with this cluster. So kubectl get nodes will return information like that. And if you go with if you go with our cloud installation, cloud training instance delivered by DataStax, then your work is going to be mostly to relax and watch what others are doing because we have installed everything already. So you have Kind already, you have Kind cluster created already, so you can say Kind get clusters. You should see only one Kind Cassandra, and you can say kubectl get nodes. You will have the nodes, and we have only one physical node, which is well not physical, but a virtual instance on EC2 at AWS. But you have kinda 6 nodes Cassandra cluster, which is great. And then the last thing we have to do all together. There is a namespaces in Kubernetes. Namespace, I hope you know already what is it. If you don't, I will explain it in just a few words. Namespace allows you to to separate your different resources, different applications into different groups to make it easier when you work with really a lot of servers, a lot of services, deployments, and so on and so forth. It's getting very quickly very messy, and they work all together, so that's not the best way. We want it to be easier, so we go with namespaces and isolating the workloads and services. And first thing we will have to do is to do kubectl create an scas operator, and then we are going to do something with storage class. So, storage class is an interesting thing. As you maybe know, that's not easy to work with persistent data in Kubernetes because you may have some possible issues. Persistent volumes, persistent volume class, and so on and so forth. First issue when working with data, with Cassandra in Kubernetes. Very often, your storage class, which is used by default, will have volume binding mode equals on request or some that's immediate. And immediate, it may lead to some issues with Cassandra. So what we want to have is wait for the first consumer. And we have a special storage class prepared. We have multiple of them, to be honest, because we have here typical storage class for Minikube, typical storage class for Google Kubernetes engine, and here we have storage class recommended for Kind. You can go and watch them directly here. So for example, the file for Google, I will make it a bit bigger. Oops, now it's hidden behind of me. Good. So now you see this class will use different kind of a provisioner. So Google Compute Engine and some special parameters dedicated, for example, for Google Kubernetes Engine. And what we will do is we will create this storage class. So we will use it for our Cassandra deployment. Now, done with the explanations, I will go to my instance and do that literally, and you can do it with me. And we will have a couple of minutes break for you to fill the requirements and follow the things. So I've just connected to my node. I will make it bigger again. Then you are connecting to the cloud instances. What you may want to know is you need to use the user ec2-user. And therefore we SSH to the nodes like SSH, ec2-user, add, and then your node, the link you receive it. But it should be explained in the email you've received. Good, so I'm in the node already. I am located in the KubeCon workshop folder by default. And I have here my repo already cloned. So I can start working with Kind. First of all, I may say Kind get cluster, Kind Cassandra. And now I can say kubectl get nodes. And that's my gorgeous Kubernetes workers. And I have 5 of them and 1 control plane of Kind. Good. Then, next thing I have to do, I have to create the namespace. As said, we will work today with the namespace, and this namespace will be Cass operator. You can use your own, but I do not recommend you to use some different, because, well, our instructions are designed to work with the namespace Cass operator. Oh, okay, I've created this one already, sorry. And then, next thing, if we get storage class, kubectl get storage class, we have only one with a local path, blah, blah, blah. So we will use a new one. We have here created one designed for this workshop, and we will use this storage class. So I simply copy paste this command. Let's see what's going on with this command for a second. First, kubectl, well, you know what is it? -n Cass operator. So I specified to work in the namespace Cass operator I've just created. Well, apply requires no special explanations here, and I will load my changes from this file. And I run this command, and class is created. Next thing I want to do, I want to see what exactly was in this file. That's the recommended storage class manifest to use with Kind. It's, well, basically very close to one we had, but doesn't matter. I just want you to very clearly remember, you have to take care of your storage class if you're going to persist your data, especially with Cassandra. That's a serious thing. Don't take it too easy. Then, next thing. If I get for the storage classes, I will therefore get my storage classes right here. One I've created and one standard. Very good. So, congratulations. I'm done with the prerequisites. And now you have to do, if you have a cloud instance, you have to do the same. So create the namespace and create the storage class. as it explained in the DataStax Academy KubeCon Cassandra workshop. Step 0, set up your cluster DataStax. If you set up your cluster own, you may have some more work to do. But again, don't worry. If you have Docker, you have your own laptop, you can do those exercises any moment after the workshop, and you will have this workshop recording, so there is no need to run right now. If you cannot use cluster, if you cannot use your own laptop, you can yet request a cloud node from the jack.fryer@datastax.com. I hope you are fine. So now 5 minutes break, or 5 minutes for you to execute the commands and play a little bit with your kind. But please don't ruin everything. But we have to, because we are going to do some much more work. And we are doing a little pause for a moment. Okay, so how are you doing? Good to go. Very well. If you are a bit out of time, that's very fine. Again, you can do the exercises after the workshop if you use your own instance when you have plenty of time, and if you are using our instance when you have at least 24 hours more to do the exercises. So don't worry too much. Good. So starting control pane, it may take some time. So first of all, you have to download them. If you are running on your own, when you have to install kind, when you need some Docker images, and you are going to download those images, and they are not so small, so that's very can take the things, very can take the time. Chat is also happening on YouTube. Is it best to ask questions there or here? Well, at best it asks questions at Discord, so they will stay with us forever. And I think we have people both in Zoom chat and YouTube chat. Good. Yes, and I'm very agree with Ulf Engels. Inserting cafe. Yes, we definitely need some. So we have to move on. And yes, with cloud instance, it should be quick. And if you have all the requirements installed, then it should be also very available. Oh, question, where can I get a cafe? Well, you see, as long as a cafe is like a very mystical thing, it's not so easy. You cannot just say kubectl get cafe. You need to find the local store where you can get that, and like that requires you to go to the street. Maybe it can be, like very unusual experience, but I recommend you to try, because some of the cafes or bars or restaurants are very, very, very nice. Good. Yes. So we are going to move on. And oops, what's happening with my laptop? Very well. And we are going to proceed with Kubernetes operator, but before that, I want to do something special. I want to ask you questions about Cassandra, because, well, I was almost 1 hour speaking to you regarding the Cassandra, and now I want to check how good I did my work. And there is a next question with menti.com, and I kindly ask you to go to menti.com and use code 5163695. I repeat, 5963695. And now the quiz starts. First part of the quiz. So 2 rules. First rule, you answer fast to get more points, and you answer correct to get any points, because if you answer wrong, you will get 0 points, even if you answer it the fastest one. So please join me at Menti. Easiest way to go to Menti is to use your own mobile phone, open menti.com in a browser and use code 5163695. And I will wait for some more people, because I see we have people, and I want you have here, and I want everyone to be able to win some swag from DataStax. Hey Jack, are you with me? There is a special gentleman called Jack Fryer from London, United Kingdom, and he's going to send you some swag if you win in this competition. So jump into Menti. Like I see 128 people. That's not serious. I want to have more. I want to have everyone here. 132. So 5163695. Go, 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 go. Okay. So we can't wait for too long, and we have to start. The quickest one wins. And the most correct one, of course. Menti. Okay, Cassandra quiz time. Hey, Menti. Okay, looks better. So now please focus at your phones, because YouTube has some luck and Zoom may have some luck as well. So read the questions in your phone's browser. It will work faster. Okay, we have many people and we can start. No results yet. Let's start. I'm sorry, Menti is behaving every time when we have so many people. Mostly probably they aren't using Cassandra. Yes, so we are going fast. How do you scale a Cassandra database? Menti. Menti is behaving again. Yes, so answers. Add faster hardware, increase the scale factor, add more nodes, stack nodes until they reach the desired height. Correct answer, you scale Cassandra database by adding more nodes. Increase the scale factor, you maybe mean replication factor. It helps you to have your data on multiple nodes, so it helps you to have some maybe higher fault tolerance. But scaling a Cassandra database just requires more nodes. Okay, next question. Sorry, first leaderboard. So let's see who is at the first places now. Tiger Baby, first place. Dr. Centipede, wow, second place. And Brandon at the third place. And we have more people in the top 10. And now notice only 3 winners get the prizes, but we still have a lot of questions regarding Cassandra and Kubernetes. So we will move on. And the points are very close, so it will change, trust me. Answer fast to get more points. Cassandra database can be deployed on AWS only, any combination of on-premise and cloud provider, only one of the following: on-premise, AWS, Azure, or Google Compute Platform. What would you choose? How would you answer? Answer correctly but quickly. Okay, so Cassandra can be deployed on any combination of on-premise and cloud providers. Meanwhile, I will ask you one more question. How do you think, what is the biggest Cassandra deployment in the world? Which company uses Cassandra the hardest way, like the biggest pressure, the biggest amount of data? You may think a little bit, and let's take a look at the leaderboard, and I will answer after that. So, leaderboard. And are there any changes? Are there any mistakes by leaders? And how it comes? Okay. So there are some changes indeed. Tiger Baby keeps the first place, now making already some difference. Well, of only 11 points, but still. Again, very fast. Brandon gets the second place, and Idvar, I'm sorry if I read it wrong, gets the third place out of nothing. Congrats, and Bjorn is very close to the top 3, but not in the top 3 yet. So let's see how it comes. Dr. Centipede, get back, we wait for you. And now the answer, what's the biggest Cassandra deployment in the world? Biggest, at least known Cassandra deployment in the world, belongs to the Apple, and it consists of more than 100,000 servers. It operates some dozens petabytes of data. Maybe getting close to hundreds petabytes already, we don't know. Apple is very secret lovers in this case. So next question. Answer fast to get more points. The recommended way to achieve immediate consistency is to use read-write 1-1, read-write 1-all, read-write quorum. I'm really curious what you would answer and which changes we would have after this question. Time is up. And the correct answer is read-write quorum. This way you always have immediate consistency. And read-write 1-all, it will work. So 69 people told read-write 1-all. It will work, it's the immediate consistency. Correct, but it's not the recommended way to use immediate consistency. Let's go. And read-write 1-1, it's a very good way to a weak consistency, which mostly probably for the regular data you don't want to have. Although in some use cases it may be a good choice. Sometimes you care only about the performance, not some particular bits. But that's not for regular data, let's say. And what do we have in the leaderboard? Who failed, who jumped in? So, yeah, so Bjorn Fernhomberg was very fast, but again, still 4th place. But we have a new person on the 1st place. Brocode, congratulations. Got to the 1st place, but I haven't seen this name before. That's good. Tiger Baby was moved to the 2nd one, and Eowyn MC is the 3rd one, like we have some serious changes. It took some time to answer this time. Good. And that's it with the Cassandra quiz, and we will have the 2nd quiz regarding Kubernetes things. But stay tuned, we still have to do some things first. Kubernetes operators. I see a message from Claudia. On my phone, it's switching from loading result to loading the next result. I can tell you, when we have hundreds and hundreds, or in some cases thousands of attendees, there is no reliable service for online quizzes at all. We tried all of them. We have problems with all of them. Mentimeter brings problems from time to time, and I'm very sorry for your bad experience with Mentimeter. But it's the best one at this point, at least for us and with our workloads. Good. So, Kubernetes operators. When you start to handle things with Kubernetes on your own, you have really a lot of things to do, especially if you run some complicated things and you have a distributed application, microservices or service-oriented architecture. You may have some dozens of microservices, 5 different databases, and so on and so forth, and so on and so forth, and you have different deployments, replica sets, services, ingresses, blah, 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 blah. That's not easy to work with Kubernetes very often. And like that's a typical thing, how many things you may consider when you're running a pod. And there are very many different operations for you better to know, because otherwise you may run into some troubles one day. And operators are to simplify these kind of things. But before we switching to operators, we want to discuss some minor set of things you should know. Some of you know already, so I will be very quick. First thing, stateful set. When your application or your service is stateless, you have nothing to worry about. But when you have to persist some data, when you work with a client data, you want to be available all the time, when you need to know how stateful set works. So you need to have persistent volume, and your pod, which is using this storage class, will make a you make this persistent volume claim to get this persistent volume of the storage class, to get a proper connection and to be able to store your data in persistent manner. I will not spend too much time on that because we still have a lot to do. But in general, things what you have to remember: storage class, persistent volume, and claim to get this persistent volume claim. Some more primitives we are thinking of. Service. Service is a thing which define the group, how to say, not better group, but the set of pods working together as a named abstraction, able to react to the same queries, and service defines the way to contact with this group of pods. And there is an interesting thing. Service in the Kubernetes is not the same as we use it to think of a service in the normal application thing, because normally we think of a service like one process running, responding to some questions, for example, or I don't know, service, an API service answering your queries. In Kubernetes, service is a different thing. Service is a group of pods which work together with some ports open and dispatching your things, but behind the service there can be really a lot of services. Services from a traditional point of view. So there may be a little naming collision, but don't take it too close. And network policy obviously explains, sets some network traffic, what's allowed, what is not allowed within the cluster. Then, last primitive I want to talk about today is config map. Config map holds configuration data for pods, and secret holds some secret data, again, for pods to consume, to work with. Now, those all were Kubernetes built-in primitives, so manifests, types supported by Kubernetes natively. But if you manage a very big distributed system on your own, it's going to be very hard for you. For a very simple thing that's... give me a moment. Sorry everyone, I was too big again. So, then you have to define manually everything. It's getting hard. And what do we do with that? We want somehow to simplify our work. I mean, I always say, good engineer is a lazy engineer. Good, if you always must be looking for some ways to optimization, to make it easier for you to do the job. And here comes operators, and operators deliver the first thing, custom resources. So first thing we speak about the operators is the custom resource definition. It allows you to create your own or reuse created by someone else, like DataStax's Cassandra operator, ways where you not describe your pods, policies, network rules, your deployment strategies, but instead of that, you just use, prepare it for you, for example, Cassandra data center definition, which is not known by Kubernetes by itself, but it was created as a part of a Cassandra operator. Sorry. Good. So, Cassandra operator, Kubernetes operator, sorry, is a tool making your work easier handling some things, and we will use multiple operators today, and you will see how easy is that. Operator is a thing is an application basically which runs on top of Kubernetes, behind the Kubernetes API, and it makes easier communication and setup of multiple resources using only one simple definition. Good. And you know what? I want us to do first Cassandra operator in deep step, and then we will get back to Menti. So, Cassandra operator in deep. What is the Cassandra operator? It makes proper token ring initialization. First, very important thing. So notice, when you just start a cluster, if you will start all the nodes at the same time, you will have conflict because the cluster and the ring is not initialized by itself. So in general, you first start with one node, make it bootstrapping, and then you start to adding more nodes. If you do it manually, you may create this deployment, you may have this persistent volume, claim, blah, 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 blah. But if you don't handle it manually, then you will have a collision in your cluster, and that's bad. Cassandra operator solves this problem. You say, run, give me the Cassandra data center. Operator takes care of a proper bootstrapping one by one. Seed node management. So which node will be a seed node? I didn't explain you a seed node thing, but it's very, very, very simple. First, no masters, no slaves. Cassandra is a masterless system, no single point of failure. So as every node is a coordinator, also every node is the seed. So what does that mean? Seed is the node which is able to dispatch you information about the cluster state at this moment. How many nodes do we have? What the IPs? What's the token ranges? Who is responsible for which part of data? When the new node is joining the cluster, it knows nothing about the cluster, and it needs to ask someone, like, what's going on here? And then you give this, hey, that will be your seed. Your new node goes to the seed and asks, like, what's up? How it goes? What's happening here? How much we have load or something? How it goes? How it works? And receives the information and joins the cluster. After that, it doesn't need any seed nodes. It joined a cluster already. But the same thing's happening with your application. When you start your application, you are using Cassandra driver. Cassandra driver is an extremely smart application, seriously. It also understands the schema allocation, a node, like network timing to different nodes, and so on and so forth. So when you start application, your driver needs to contact at least one of the nodes, load the data, load the schema, load like how many nodes do we have, what's the IP addresses, and then it starts to do all the load balancing and know which nodes to ask, and so on. So it loads cluster metadata. And Cass operator does this seed node management thing, which is great. So again, you don't have to care of it manually. Then it defines this custom resource definition, Cassandra data center, which is the main definition for Cassandra data center. In Kubernetes, we will see it in a moment. It also allows us to have a rolling reboot for nodes if we change something in the configuration. If we change something big, we will have a rolling restart, a rolling update. You will see it today. And moreover, you will do it on your own today. Then, it also defines things in a way like Cassandra is very smart, so it realizes we have to store data in different server racks, or if we speak of a cloud, in different availability zones. So it's also considered by Cassandra operator. Automatically replace dead unrecoverable nodes, and so on. Good. So many words. Let's start to do something. Typical custom resource definition for Cassandra data center looks like that, and you may see it in our files. So in a moment, and what's the most important thing for us here? You know what? I would better say show it to you on the file, on the real file, not on the slide. And so then Cassandra operator creates the data center as we ask it for. There is really a lot of things happening. Even if we have one single pod, so we are going to have like one single node, we will have to take care of the webhook, security, operators, storages, classes, volume claims, secrets, users, pods, and so on and so forth. All of that is done by Cassandra operator, otherwise you would have to do it manually. Stay lazy. Then, so what's inside a pod? I will show you in a moment. In the real Kubernetes, you will see it on your own, but we have to remember, so what every pod has two main services in the old meaning of this word, or two main processes to consider. Cassandra by itself and Sidecar. Sidecar is a management API for Apache Cassandra. It's kind of an HTTP server service, which you may ask for some details like, hey, your neighbor Cassandra, is it fine or is it dead already? How it goes. It also allows to require some operations with a Cassandra, like maybe restart it or something, and so on and so forth. So every pod consists of Cassandra and a sidecar. There is a lot of different things Cassandra management sidecar may do. So start, stop, operations, changes, managements, and so on. And Kubernetes health checks, of course. Good. Typical operation with Cassandra operator, you will do it on your own in a moment, is scaling up. So in this case, we will increase the state for the data center 1 from 1 to 3 nodes to have it more reliable way. And actually, you know what? Let's do it. Because, well, talk is cheap. Show me the code. First, oops, wrong side. So I go to next step, and now we don't have any separations. We all at the same board and on the same task. Deploy a Cassandra cluster with Cass operator. And first thing we are going to do, we are going to install Cass operator. It will simplify the process of deployment and management of a Cassandra or DataStax enterprise. So we have a lot of different things: service account, role binding. That's not what I want you to take care of right now. If you would installing Cassandra in Kubernetes on your own, then you would have to. But again, we want to stay lazy, stay efficient. What we will have to take care is customer resource definition. So first thing, we have to install Cass operator. And let me start with that. So kube control namespace Cass operator apply file. And I will ask to apply this file. And a lot of resources were created. And we have service account. We have secret prepared, customer resource definition, Cassandra data centers imported, cluster role binding, roles for authorization, role binding, service, webhook service, deployment for Cass operator, and many other things. If we would watch this file, I mean, show this file, oops, of course. We will see really a lot of things. So that's all what defined for us by DataStax, and that crew what working at Cass operator did a great job, so thank them so much. Then we want to watch how it goes and how this application works. There is a little bit of funny thing. What is any operator by itself? It's the same Kubernetes pod. So you have it running as a normal pod, and that's this Cass operator application, which runs as pods and it schedules all other pods. Now we have Cassandra operator installed and running, but no Cassandra. So that's a good time to fix that. Yep, I will create a Cassandra single node cluster. work is the same. kubectl apply cas operator namespace apply file. So Cassandra data center, Cassandra data stacks.com dc1 created. And what's that? Let's take a look. Again, I will just open this file. This one will be shorter. And we see this interesting thing. Kind of this manifest. It's a Cassandra data center. It's not a native Kubernetes type. It's not a native Cassandra Kubernetes kind, but it's a custom resource definition prepared by DataStax Cas operator team. So we have some specs here. Cluster name, cluster 1, which version are we going to use, which storage config we are going to use, and some settings for Cassandra as well. So we can define some JVM options if needed, and we can define for Cassandra which authenticators we are going to use, for example. Very well. So now I want to watch pods. And there is a thing happening right now. So first pod we have seen already. It's a Cas operator by itself. But this one is the first Cassandra node of our famous cluster. And readiness is a bit weird. So why this one has 1 of 1 and next one has 1 of 2 and 2 of 2 already, just change it. You notice it? Why? I explained a little bit some minutes ago what every Cassandra pod has 2 processes. One is Cassandra by itself and one management sidecar. Management sidecar was much easier to start, so it started the first. And then Cassandra starting a new cluster, starting all the things, it took longer. But now we have this pod fully operational. Good. So, we may again take a look what's going on with our data center using already, not just watching the file we applied, but using describe a Cassandra resource. So CasDC is an alias, short name for the custom resource definition Cassandra data center we are having. Like you may type service or you may type SVC. That's the same. SVC is just an alias. So CasDC is an alias for Cassandra data center, much less to type, and DC1. And there is some interesting things we may watch. So not only configuration we applied, but also some more nice things. For example, on the bottom, you may see history of this Cassandra data center. And we see all the things. We created super user, created users. We started Cassandra for the pod. We labeled pod as a seed node because it's the only node, so it's of course ready to work as a seed node. We don't have any others to choose. We created stateful set, so we have our persistent volume. And we created service, all pod service, seed service, and DC1 service. So that's DC1, cluster 1 DC1 service is the main Cassandra service, how nodes will communicate with each other. And seed service is a service to load other nodes when they are joining. So this service will be used when we will join more nodes. This one is interesting. Well. Racks not count, it's not so interesting for us right now. But we want now to join Cassandra and get some deeper with the Cassandra. So, first we are going to jump in, and as we have roles, secrets, password, you may guess we may need to get some credentials out of that. So, first thing we have to do, you have noticed that maybe we created a secret, or not we, but Cassandra operator created a secret for us. And we will do this, we will execute this command. So, some things happened. First, what was the command I've executed? kubectl-n cas operator, namespace cas operator, get secret cluster 1 super user. That's the default name, so we are just getting it by name, we know. We get it as a YAML. And there are 2 very interesting fields for us, password and username. And that's not the real password in username, but we have to unpack them. But that's what we need to connect to Cassandra. So very well, how do we do that? First thing, we have to decode username. And well, I will not do that because I know username already is cluster1 super user. But I would also get this result if I would take this one, username, y2 blah 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 blah. It matches basically because it's the same. And unpack it with base 64 algorithm, so I will have cluster1 super user. Every one of you will have the same result because it's the default. But password will not be the same. So we are going to unpack password, and I will do it like this. So first I will need echo when I need my password, when I need the last of this command. I will simply copy paste that. Notice what you have to do that on your own instance because you will have different password, and enter. And now I have my password. That's my real password already, so I can use it to join my cluster, to dive into the Cassandra. So now I'm going to execute exec command. Well, execute, exec sounds a bit repetitive, but that's what I'm going to do. What's happening? I'm with the exec command, with kubectl, it's like a Docker exec command. It allows me to join a running pod, a running process, and I will do kubectl minus ncas operator. That's all should be familiar. Exec minus it to allocate interactive terminal. I'm going to join this cluster dc1 default sts0. So that's my Cassandra, and I will need a bin bash allocated for me. So I'm going in through the time and space. Good. So we are in this Cassandra process, and we can see Cassandra pod, and we can see some processes are running within. So we have collect D, so we have some resources to, some metrics to take care of later in the last part of the workshop, Cassandra by itself, management API, and so on and so forth. So what I want to do now, first I want to say node tool. Some of you status, node tool status. Some of you may know this comment already, and some of you may not. That's node tool is a Cassandra built-in tool, well, which helps you to operate with different nodes within the Cassandra cluster. In this case, I say node tool status. So node tool is a Cassandra tool, doesn't relate to Kubernetes. And status, well, needs no explanation. And what I see, I have data center DC1, some explanations about the statuses, and that's my one and only node. It's located at rack 1. It's responsible for Docker ranges basically for all of them because I have all the nodes, and I can see it as well. It owns 100% of data because we don't have any another nodes. It's the only one. So we have to add some more. Host ID, some data preloaded already, IP address, and the status, most important for me, up and normal. So it's not leaving, it's not moving, it's not joining. It's already fully operational. Great. Now, we're gonna start a SQL-SH console. What is the SQL-SH? I don't want to spend too much on that, but if you have worked with SQL, so structured query language, you will understand C, which is a Cassandra query language. They are a bit similar. And SQL-SH is Cassandra query language shell, so that will allow me to communicate directly with Cassandra very well. And I'm saying which node I'm going to join. I will use username. I will use my password to join. So first of all, I need the first part of this command. And now I need the password. Where is my password? That's it. Good. Perfect. So now I'm in my pod. in my Cassandra, connected directly to Cassandra with Cassandra query language shell. And now I'm able to communicate with Cassandra. So, first thing we are going to do, very simple. We are going to create a key space, and I will spend a moment here to explain you a couple of things regarding the Cassandra, otherwise you will not get the idea. First, let me scroll it up a little bit so you will see that. I'm talking about this command. First of all, if you can read English, mostly probably you will understand more or less what's going on here. That's Cassandra query language. It's easy to use. So we are going to create key space. What is a key space? Key space is a container for tables. So you may say schema maybe, or database maybe, if you more use it for relational databases. Good, and you know what, as I'm working all the time in the console now, I will make a little trick and move myself to the right, so I will not, boom, okay, now it looks much better. So now I will not hide comments. Thank you, Eric. So I create key space, I create container for tables. If not exists, it will be named killer video 1. And now interesting thing happens. So now I'm exactly explaining Cassandra what's going on to happen in the future, because we have, well, Cassandra database, but now it's empty. So first thing, when you define a key space, you may define really a lot of different configuration settings, but you must define two things: replication strategy class and replication strategy replication factor. What does that mean? Class, that's very easy to get. There are two classes currently, nowadays: network topology strategy and simple strategy. Simple strategy is good for your laptop and bad for everything else. Simple as that. And network topology strategy, as you could guess, is network topology aware strategy. So this way, Cassandra will analyze which racks or availability zones is deployed and replicate data in the way so you have always data in different availability zones, for example, or different server racks if you are hosting on premises or on your own data center. And then, what's this number? Try to guess. What does that mean, 1? It's a replication factor. We just discussed it a moment before. That's replication factor. We recommend to have 3, but currently we have only 1 node, so we cannot set replication factor 3. And I set for my data center 1, replication factor 1. If I have more data centers, I may have data center 2, or data center west, or data center something. And I may say different replication factor for different data center. But in this case, we have very simple thing: network topology strategy, data center 1, replication factor 1. And never mind durable writes now, that doesn't matter. So good, so far so good. We have created the key space. It means what we could start using now Cassandra for real. Good. And we can ask Cassandra to describe key spaces. So we go describe key spaces. And we have 6 key spaces so far: system schema, system of system, system distributed, system traces. That's all what relates to the Cassandra internals by itself. We will not dive into that. But killer video is a key space I've just created. Then we are going to load some data finally. I will use my killer video 1. So we now attach to this key space. And I'm going to create a couple of tables and load some data. First, I'm going to create the tables. Again, should look pretty familiar for you. Create table if not exist. Column name, column type. So no big things, no big changes, but there are a couple. Join our Cassandra workshop to get a deeper dive to one of the most powerful databases in the world. That's really worth it. But for now, we will not make a deep dive into that. So I will simply create these. Boom, so we have tables. And I will load some data into these tables. Very well. So, and we can load this data. Select all. Don't do select all in Cassandra. It may lead to some terabytes of data. Select all from users. And we have the users we just created, which is good. The same way we can get some from videos. And we have some videos as well. But in general, so that's a KubeCon, and there are a lot of operations and DevOps people. I will tell you one very important thing. That's not a Cassandra workshop, but it's really worth knowing if you're working with Cassandra. Remember always, if you see in the code of your developers things like that, with no limit, no conditions, no nothing, or if you see even worse thing, if you see something like that, immediately take the keyboard of the one who is typing that and not let him or her type that ever, because it basically may destroy and paralyze the database, because allow filtering will allow Cassandra to do very bad things and trying to query all the data. And as long as you have one server with a couple of small tables, it may work. But as long as you have hundreds of servers with petabytes of data, it's a very bad practice. And if you want to ruin things, then allow filtering is the best way to ruin things. So that's like a small hint. Watch for these kind of things. You don't want to do it in real life. For real. Okay, so let's get back. So we just attached to Cassandra, created tables, created key spaces, and lots of data. We are going to work with that again in a moment. Good. So I'm going to quit, and I'm going to quit. Very well. So we have only one node Cassandra cluster. In the very beginning, I told you that's not the way to fill the Cassandra power. You need multiple nodes. So let's make an interesting thing. We are going to scale up our cluster, and I'm going to do this diff first to see which kind of a change we are going to apply. And this kind of a change is very simple. Now you see the command. I'm going to apply this file, Cassandra cluster 3 nodes, YAML, and the only difference between first file and second file is size 3. So I bet you could guess what are going on to happen right now. If I open this file, it will look exactly like a previous one. It will still be the same Cassandra data center with all the same things. That's the only change, size 3. Well, so far so good. Let's apply this file. Now, DC1 configured. What does that mean? Let's take a look. I have a nice command here, call it watch get pods, and we have that one Cassandra cluster 1 data center 1 stateful set is operational with management API and Cassandra by itself, and 2 more are starting. Why? Because I told what I want to have this Cassandra data center having size 3. So now we have more nodes. That's how it goes. It may take, usually takes around a minute, given we have no workload and no real data to load in general. While they are starting, I will tell you a thing. In the very beginning, I told you what we may have like 1 terabyte per node, but some companies prefer to have smaller amounts, and some companies prefer to have higher data density, to have 2 terabytes or 5 terabytes and so on. What's the trick? What could be the difference for us? If you prefer to have smaller amounts of servers with big amounts of data, well, it's understandable strategy. It saves you some money on servers and so on and so forth. So I'm not saying it's bad. But there is another thing to consider. When you have like 2 terabytes per node, which is not the best practice in general, because that's a little bit too much, and you are starting a new node, then Cassandra has to reshuffle the partitions. So some partitions will be moved to a new cluster. So we are scaling out with a new node, to this node, sorry, to move data to this node. And obviously you are going to move somehow 2 terabytes within the cluster or around that. And that's not the easiest, the fastest way to do. So if you want to have dynamical infrastructure, like your company is in e-commerce and you have sales and you are waiting for Black Friday, you may want to double your cluster size for a couple of days and then take it back. And with this strategy, it may make sense to have smaller data density, smaller nodes, when you will be able to start new nodes faster. And smaller data shuffling and moving data within the cluster, when it will work much faster. So which data density to choose, it's a part of your strategy. Good. So second node is ready and third node is almost ready. Let's move on. Blah, 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 blah. So those investigation you can do without me. What I want to show you next, to see what's inside a pod. Yes, that's not important for us as well. And yes, let's do this part. That's one of the interesting things. So, oops. I'm going to do the command you've seen already. I'm doing exec to join my Cassandra service, and I'm going to join, oops, too early. I don't need shell right now. What I want to do node tool status. Wanna guess what will happen now? Yes, we have 3 nodes and all of them, 2 nodes are joined already. If they would be only bootstrapping, it would be UJ. Status up, state joining, but it's already up normal, so it's joined the cluster already and fully operational. And now notice interesting things. You remember the first node owns 100%. Now this node instead of 100 has only 22 and 6, 47 and 4, and 30%. What does that mean? It means what the partitions and token ranges were spread over those nodes. And every node, given we have this replication factor 1, will have the following partition sets. Oops, it was a mistake, but doesn't matter. So the data will be spread all over these 3 nodes. If I would add 2 more nodes, therefore every node would have approximately 20%, plus minus. Very well. So we have these things. So now I want to do interesting thing. I'm going to jump in the Cassandra back. Well, and I want to do describe key space killer video. And there are a lot of different things, blah, 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 blah. But what's important for me is this one. So that's the Cassandra data center. Call it DC1, and it has replication factor. What does that mean? We have no redundancy. As soon as we lost any of those 3 nodes, we basically imagine if we lost node 2, we will lost almost 50% of the data we have. That's not what we want. We want duplication. We want our data to be redundant and spread it over multiple nodes, so it's available always, 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 always. So we are going to change something. We are going to change replication factor for this key space. And we do it following steps. First, I'm alter key space killer video 1 with replication. Network topology strategy still the same, but replication factor will be 3. Nice. And that's not enough. Notice an interesting thing. You remember I told you about the consistency levels. Again, that's very sweet feature. You can set consistency level per query. So you may run 3 inserts in a row. First insert into table, blah, blah, blah. First insert with consistency level 1. Next one immediately with consistency level quorum. And last one with consistency level all. That's for you to define how do you treat your data and which kind of data. So now I'm setting consistency. So what's my current consistency? My current consistency is level 1. Understandable. So what I want to have is consistency quorum. Consistency level set to quorum. Now, interesting thing is going to happen. I will enable tracing. Tracing will show me, well, tracing will show me what's the status of the request, like what logs of the request, let's say, I'm going to do. You will see it in a moment. And now I'm loading a data from the table videos. And there will be a lot of data. Boom. So I will make it a little bit smaller. Otherwise it will be hard to see. Give me a moment. Okay. So that's the trace of my query. What happened and which part happened, at which moment happened, at which node happened. So that's the trace of a query through all the servers it's touched. And this one was processed by a local one, by this one. And there is a lot of things like sending read message to cluster 1 seed service. A lot of job happened in the background. And what's the most interesting to me? So first of all, that's my output. 0 row. My ID must be wrong. Okay. Ah, correct. Yes. Use killer video 1. Select all from videos. Ah, tracing is still enabled. Yes, where is my data? Very well. Yes. That's my thing. And what I wanted to show you here. Yes, correct. This line. Read repair message received. So that's actually, sorry, this one. Sending read repair message. So we had one node and we loaded data. Data was loaded to the first node because we had only one node. When we added 2 more nodes, we joined the cluster and we tried to read the data and we set the consistency level to quorum. It basically reads to the situation when one node has our data and others don't have, and when we do a select query. And problem, inconsistency. One has, others don't. So we receive data and we initiate read repair automatically. Now you may ask, hey Alex, you told us Cassandra is smart and I'm joining new nodes and my data is not distributed to the other nodes and we are in inconsistency. What's going on? Answer is very simple. That's exactly because Cassandra is smart. Now we have 3 nodes with altogether 6 records, but imagine we have 1000 nodes with petabytes of data, 2 terabytes per node, and you add a new node, or 10 nodes, or 100 nodes, or maybe 1000 nodes. The immediate shuffle of the data over your Cassandra nodes or Kubernetes cluster will just block all your networking to just only reshuffling the data. That's why when you add a new node without explicitly explaining, you want it to load the data, if not tool command, it will not load data as long as you don't ask for it, because that's for the human to decide when to move the data. Maybe you want to do it in the night when you will have smallest amount of customers. Maybe you want to move only part of the data, and so on and so forth. So Cassandra is smart. That's why Cassandra doesn't move all the data automatically, but let you to decide when you want to move it. Good. So now I want to show you one more incredible feature of Cassandra operator. We are going to change some setting, and it's going to be a big change. Oops. I'm doing again a diff of a file, last one to the new one. I'm going to apply this file. That's Cassandra cluster 3 nodes new config, and there is only one difference. Commit log sync period in milliseconds, 11,000. Let me watch this file. So what's this line? What does that mean, commit log? I will not explain you how commit log works, but in general that's write ahead log, one of the internal Cassandra mechanisms to ensure persistency even in highly unstable environments. So that's one more config parameter for Cassandra YAML file. Commit log sync period is 11,000. It's not the default value. So Cassandra nodes were initialized with different commit log thing, and commit log change is a serious change. It will require node to restart. Now, how we are going to apply that? If you don't have an operator and you just put this change and you say like apply to all of them at the moment, what would happen? It will be applied at the same moment. And what does that make? Downtime, because your 3 nodes will be restarted. And starting of a node, it's like it takes some time to start a node. So you don't want it to have like this. And what you want to have is you want your Cass operator to do the job. When you apply the file, a change to Cassandra data center, Cassandra operator will process that. And now let's watch a thing. Only one of the pods will be terminated at once. It's so-called a rolling upgrade. So this way we ensure that at least 2 of the nodes are always available and one will be terminated, like it's happening right now. So it's leaving the cluster at this moment, and when it will be created again, and only then it's fully ready. When operator sees what okay, it's joined the cluster, we are good, we are fine, we can proceed. When it's up and normal, when we start to put the changes to the second one, and now it was terminated, now it's initialized, API management sidecar is initialized, now we will have Cassandra running, and who knows what happens next? You know. Next one, Cassandra cluster 1, data center 1, default stateful set 1 will be terminating. So I expect it to be in approximately 20 seconds. Wow, this is awesome. Yes, this is awesome. Seriously. Yeah, and well, I've lost the moment. Yes. So the stateful set 1 is terminating, and therefore we will have a new pod with the same name running very soon. Good. So Cassandra is down, API management is to be down in a second, and next one will be initializing. And while it's happening, I will switch to the next operation we want to see. Just to save us some time. If after that you ask kubectl to describe pod, this one, so it's our good old first node, you will see the changes. And you will see, where is it? Should have missed that. Where is my change? Okay, so you will have some logs here. That's clear. And I want to find Cassandra YAML value. Yes, that's it. So I want to find it. Where is that? Okay, it would be better to see in this one. So number 1 and number 2 are ready. Number 0 is restarting. And I want to... Okay, this setting is here. Yeah, well, but we changed this file. Ah, of course. And I want to describe pod. And pod name was something what was restarted already. Yes, but I will get the new one. Good. Oh, here we go. Config file data. So with config file data, Cassandra works with a real cassandra.yaml file, like normal file. And in this file, Cassandra operator took this config file and put it into the config file data for us. So we have this commit log sync period in milliseconds, 11,000, and it's applied successfully. Very well. So I've even shown you at the real live pod, which is great. And we are done, and I'm done with this exercise. It's now your job to do this exercise. And exactly after these practical steps, we will go with the second and last part of the quiz. So stay tuned. We do exercise steps now. I will join you in a second to answer your questions. So once again, to do the exercises, we go to DataStax Academy, KubeCon Cassandra workshop, and we need step 1 Cassandra. It's available from the main page. Right here. And those are all the steps we are going to do. And you know what? I suggest you now not do all the steps thoroughly within 1 hour, but I suggest you to do the main things like within 20 minutes maybe. And this way we will have enough time to do the last step of the exercises and quiz. Just a warning, we start last second and last part of the quiz in 4 minutes. Okay, so 1 more minute to get you back, and we start the quiz. Okay, so we are doing well, and let's get closer. We are going to have some winners today. I hope this time Menti will work better for us. So let's start. Let's start. We can't stay here for a whole day. Menti. Okay, it looks like I have to reload Menti page. Sorry, it will take a moment. Okay, start to look better now. Don't forget, open Menti at your mobile phones, not browsers. And we are about to start. Let's even bit more time because of a little delay. Okay, Menti is loading. Okay, while we are loading, okay, it's almost done. While we are loading, do we have any good questions from attendees? So I would ask live, like very, very, very best question. Okay, I think we can proceed. Hopefully, it looks better. So attention, I think question is going to appear in a moment. Okay, Docker container is an image of software stored on disk, lightweight standalone executable package of software, A file used to configure a Docker instance, something to store fish when coming back from a day on the board. And time is up. So I bet we will be changes. Okay, correct answer, lightweight, standalone, executable package of software. Yes. And Docker container is not an image of software stored on disk. We would call a Docker image this way maybe, but not a container. Good. And I expect some changes. So, who has lost the pace? Who has lost the place? And it's happened finally! Bjorn Fernhomberg. Willkommen, ihr seid willkommen. First place, 3,784 points. Very close. Return of the Dr. Centipede. Welcome back. And Brandon. Very back. I am Poldek is the 4th place. Oh, actually sharing 3rd place because 3,755 points. That's a very nice. Okay, next question. Last questions, so full attention, full focus. Answer fast to get more points. In Docker, how do you enable persistent storage of the application state? Okay, Menti look frozen for me. Hope for you it's better. Even if I can't read the questions, you can see them on your phones. Time is up. I hope you've seen. Okay, so that was only me who was not seeing the answers. In Docker, how do you enable persistent storage? Volumes. No state service, no persistent file layer, but volumes. Correct. Let's move on. So, anyone made a mistake from the leaders? No. And Bjorn keeps the 1st place. He was hunting down for the full wall, 1st part. Brandon conquers the 2nd place over the Dr. Centipede, but Dr. Centipede is still on the 3rd place. And I'm Poldek getting closer and closer, the 5 points difference to the 3rd place. Next question. So, in Kubernetes, what is a pod? A worker machine in a Kubernetes cluster, a set of replicas, a collection of containers what can run on a host, and well... Time is up, and I want to see leaderboard again. So, yes, correct answer is pod is a collection of containers working together. And 45 people answered what pod is a worker machine in a Kubernetes cluster. That's the KubeCon. And like, don't tell anyone you've answered what pod is a worker machine. Don't tell anyone, please keep it your secret. Organizers will not be happy. So, leaderboard. And. That's no mistakes. Okay, so Bjorn, still the 1st place now. Brandon, 2nd. But it looks like we have lost Dr. Centipede. How could you? You were so close to the win. Vani, welcome to the new top 3. That's how our lineup looks. And we are very close to the end. In Kubernetes, what is a service? A program what runs in the background, a policy what describes outgoing net traffic, a named abstraction what defines a set of pods. Something you order in your room at a hotel. That answer is obvious, kinda. Time is up, so let me see your answers. A named abstraction what defines a set of a pod is a correct answer. It's not a policy what describes outgoing network traffic. No way. And that's definitely not a program what runs in the background. In the traditional way, we could call service this way, like something runs in background. But as I said today, in Kubernetes, service is a different thing. Cool. And so leaderboard, the very last question. I want to see how it goes for you. Competition is close. Bjorn, Vani, Brandon. Okay, very well. And we answer fast to get more points. Kubernetes operator helps. Create a custom image. Extend the types of application what can run on Kubernetes. Deploy pods. And that's not an easy question. There is easy to get to the trick. So I need some music. Next time you join workshop, I will play some music. Okay. So I tried to warn you. The correct answer is Kubernetes operator helps to extend the types of applications what can run on Kubernetes. Does Kubernetes operator helps to deploy pods? Well, yes and no, because Kubernetes operator may do different kinds of a workload, including deploying pods, but not only deploying pods. So we think of a Kubernetes operator as the way to extend of the ways of applications and the way how we manage these applications on Kubernetes. And if I'm correct, that's the last one. DataStax Kubernetes operator for Apache Cassandra describes what network traffic is allowed for a set of pods, represents a customization of a particular Kubernetes installation, automates deploying and management open source Apache Cassandra or DataStax Enterprise in Kubernetes. We are out of time. And the correct answer is DataStax Kubernetes operator for Apache Cassandra automates deployment and management of open source Apache Cassandra or DataStax Enterprise. And well, represents a customization of a particular Kubernetes installation. To be very honest, I have no idea what does that mean. So that was just a tricky answer what some of you got into. And leaderboard is so will there be some changes? Brandon got the first place in the end, was crawling in the bottom of top 3 and finally last jump what brought the win. Brandon is the first place, 8,476 points. Congratulations, you have something to be proud about today. But also, Federico and Bjorn Fernhomberg, I congratulate you because top 3 of our winners, so Brandon, Federico and Bjorn Fernhomberg, are getting the prizes from DataStax, and I congratulate you with this win. And please contact Jack Fryer at Discord or at jack.fryer@datastax.com. Congratulations again, very well done. And for the others who was close but didn't win, we do a lot of workshops at our YouTube channel, DataStax Devs. So please join us there. We will have much more content for you every week. So, let's get back. We have one last step to do. We are going to do some monitoring. And that's very important. Why? Because monitoring is something what, like, if you cannot manage something, if you cannot measure something, you cannot control that. So we are going very quickly to Prometheus and Grafana. It looks like we will be a little bit out of time. I'm very sorry. So if you can stay with us for a bit longer, that's great. If you cannot, well, recording will be available at YouTube, and we are recording also Zoom session as well. But I will be quick. So, last thing, what we have to do is we have to, first, there are two, I actually have to switch here for a moment. Oops. Very shortly and very simply, as I remember, there were some people who don't have experience with Grafana and Prometheus as well. Briefly speaking, Grafana is a tool for a data visualization and analytics therefore. So you can give Grafana a lot of different data, and you can ask it to visualize it in the way you would like it to see, and also so you can see all the things together. I want to give you an example. Yes, so that's a typical thing on the right. We will see it in the real life very soon. So you give some data and Grafana shows you how it looks like considering time and other things, and that's very convenient for monitoring and analytics as well. But technically there is no limits, and Grafana can work with nearly any kinds of data to visualize it. It's a very good tool, of course, for monitoring. And Prometheus, briefly speaking, again, it's the database and monitoring and alerting tool which helps you to gather data from very different sources, like Kubernetes nodes, but also Cassandra nodes, whatever your database nodes, application server nodes, and so on and so forth, and see how they are operating, are there any problems, and so on and so forth. Set up your alerts based on the situation, and many other cool things. So what we will do now, we will set up a Prometheus monitoring, attach Grafana to it. So we use Prometheus to collect data from multiple services and store it into the Prometheus. And when with Grafana, we are showing this data and show what's the situation. So currently we have two kinds of metrics collectors. One metrics collector or metrics exporter for DataStax Enterprise, so enterprise version of Cassandra, and one is metrics collector for open source Apache Cassandra. At the time I started this workshop, there were an issue on metrics collector and Cass operator on Kubernetes. So for today, I will terminate my Cassandra cluster and start DataStax Enterprise cluster to show you the metrics exporter, but they're basically exactly the same with metrics collector for Apache Cassandra. The fix is already in pull request state, as my friends just wrote me. So we are going to have this MCAC metrics collector for Apache Cassandra working in Kubernetes literally by today evening, or maybe tomorrow at worst. But now I will show you how it works using DataStax Enterprise. I'm sorry for that. But the use case and user operations to make it running are basically the same. So, good, that's how it will look all together. We have DataStax Enterprise with a metrics exporter or metrics collector. We have Prometheus and we have Grafana attached to visualize them. So let's do the work. I have how it goes with my pods. All my pods are running very well. So first thing, I'm going to quickly terminate one. Good. So instructions will tell you to properly stop the Cassandra data center. And that's very correct, because first we want to notify in the real life, we want to notify our nodes what they are getting down smoothly. So Cassandra operator will take them down slowly, quietly, with no big problems. And that's fine. but now I just want to delete this cluster. If you run on your own node, you can, and you have a big node, you can simply skip this step, but I want to take them down completely. So what I'm going to do is delete my Cassandra cluster. And the file which was used as the last one was 3 nodes new config. Okay, Cassandra data center DC1 deleted. So in real life it will take some time. So I have these nodes terminating, but this time it will be not a graceful stop, but like the rude one. But as it's a training instance, I don't care so much. And we have to proceed. Now then, you are going, if you are working with Kubernetes, you are going to use Kubernetes a lot, and you are going to use operator lifecycle manager a lot, but the recommended way now is getting closer to use operators with Helm. This workshop we do with operator lifecycle manager. There are another tools to do the same job, but this time we stick to operator lifecycle manager just for the simplification. First thing I'm going to do, I'm going to set up my namespace so it will stick to Cass operator. Okay, my nodes are down already. So I'm exporting my namespace to be Cass operator. Then I'm going to run a simple script to install operator lifecycle manager version 0.15.1. It will take some time, but now I will have Olm operator which will manage other operators for me. Think of Olm or Helm as like a package manager for your Kubernetes cluster. Like then on your Linux machine you can install something with apt-get, update, or yum install, blah blah blah. So think of Olm manager as of a similar technology to manage operators. Okay, deployment package server successfully rolled out. Package server phase succeed. Very well. What's my next one? So you see a lot of things were installed. That's not easy to manage operators. You could guess. Now we are going to install Prometheus operator. First thing we have to do is we have to install the operator by itself. Okay, operator group created, Prometheus created. What is it? It's a custom resource definition. The same like we did with Cassandra. Cassandra cluster is a custom resource definition as well as Prometheus in this case. Then I can install the instance of a Prometheus. You can open this file and take a look inside. This one going to be pretty simple one. Actually, I highly encourage you to open all the files and watch everything. What matters the most? First, we have there are some multiple definitions. There is a service account, RBAC authorization, again the cluster role binding, and my final here, most important for me now, is kind Prometheus, custom resource definition. Well, and that's what important. In this case, in this place here, service monitor selector, match labels, I explain which cluster it should monitor. Then I deploy a Cassandra cluster or DataStax Enterprise cluster. I have this definition, Cassandra DataStax.com cluster, label. And this label, in this case, as you could guess, is cluster 2. Will be because my DataStax Enterprise is not deployed yet. That's an important thing to understand. And then finally, I want to run the service monitor. What is the service monitor? That's important to understand. So, in the normal life, Prometheus works directly, let's say, with the exporters. In this case, we don't want to have some too direct conditions or everything. Service monitor is a thing which explains to Prometheus which service, which Kubernetes service it has to monitor. So if we open this file for a short time, there are a lot of things, and most of them, that's kind of a long file, but all the same, it's explaining target labels and how they should be converted for Prometheus to be more understandable. That's so-called metric relabelings and endpoints we are working with. And it will work with cluster 2. So it's a server monitor for service labeled cluster 2 as it's marked downstairs. Here we go again, selector, match labels, cluster 2. And that's what's important for us, and some more settings you may have to consider when setting up a monitoring, but that's already prepared. And the last point I want to do, we can open Prometheus right now. It will be running. I will forward the port. To simplify the setting up, we don't have an ingress controller for this thing. I'm just port forwarding for this service. And I can open my node. What was my node? Okay, that was my node. So port forwarding again. I can open my node. I can specify port 9019. I have my Prometheus running, but it's empty because it has a service monitor, but there is no service with this label cluster 2 is connected. Therefore, I have no targets. Okay, and then final thing, we have to add something here. I will install Grafana first. So we are done with Prometheus. And add something to visualize the data. I'm again installing operator. Grafana operator created. I'm installing data source to read from Prometheus. So data source is a Grafana definition to specify which kind, what will be the source of truth, what will be the source of data for our Grafana instance. Notice what one Grafana instance may have multiple data sources, and one Grafana may work at the same time with Cassandra, Prometheus, and many others. Now, I'm installing dashboards. So dashboard is exactly the rule for visualization, how exactly I want my data to be presented and visualized. So there is plenty of things to do. We have dashboards prepared, and as a final step, I'm running this kubectl cas operator apply blah 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 instance, which will create a Grafana instance for me. So we can now go to pods, kubectl namespace cas operator get pods, and we have some new pods here. So you remember we have had cas operator already, but we also have Grafana operator to manage Grafana. We have Prometheus operator to manage Prometheus, Prometheus by itself, and Grafana deployment, which is not ready yet because it's starting up. Okay, it's running. And finally, I still have no cluster for DataStax, so I want to enable my DataStax cluster, and it starts small with a minimal installation. I will go directly to deploy the Cassandra installation, which will deliver all the metrics enabled. Yes, that's my favorite step. Let's blow your mind. And what I'm going to apply now is kubectl Prometheus Grafana DataStax Enterprise enabled metrics. Notice once again, for this exercise, I'm using DataStax Enterprise, but there is no difference from the user's, let's say, point of view to MCAC, and we are pushing fix today or maybe tomorrow. So MCAC will work as well. And you know what, actually, I want to stay honest to you. I promised you we are going to stick to open source, and we will. So as soon as we have fix deployed to Cassoperator, I will immediately update the workshop GitHub, and we will have step here with DataStax Enterprise and separate step with open source Apache Cassandra, so you can use it as a documentation. That will be fair. Okay, I'm running a new data center, and let's watch some pods and new thing happening. So you may see the difference right here. Those two are waiting for initialization. Why? Because we need, starting a Cassandra cluster, we have to start with one node. Otherwise, we will be collision. So Cassoperator runs first node first, and lets those two wait for the first one will be ready, and then those two will join the first one. It may take a longer time because DataStax Enterprise includes not only Cassandra by itself, but also some more things like tools for a more integrated search, for analytics, and so on and so forth. So there are more things to run. You will notice it will take not like around 50 seconds like it usually does with Cassandra, but it will take a little bit longer time to initialize that cluster. And while it's happening, I will prepare to forward my ports. Okay. Now I will run them with ampersand in the end to send it into the background. Port 3000 done. And port 1990 done. Port 1990 goes for Prometheus, and port for Grafana by default is 3000. And we can watch our pods meanwhile. Okay. So management API runs for all of them, and we're now waiting for the first Cassandra to start. At this point, we will be able to go to Prometheus to watch the targets, and then to Grafana, and that's my favorite part. And in general, if your node or your cloud node from DataStax or your own node is not so powerful, we do not recommend you to run all of them at once. I mean Cassandra and DataStax Enterprise, because it's going to consume a lot of firepower. And well, first one is running, and 01 is running. And first one and second one are going to join very soon. So let's go watch the Prometheus. Perfect. So, emergency. We have some unhealthy nodes, of course, because we haven't joined our cluster yet. And connection refused, we expect them, but they are not here. But we have one target is here and ready. And we may have a lot of data with them, and that's great. But well, Prometheus is not the best tool to visualize things. So yes, we may grab some things here, but there is much better way. instead of running with a Prometheus, I'm going to port 3000, which was allocated for Grafana. And boom, Grafana is here. Very nice. Thank you, Grafana. I'm happy to see you too. Okay, and now email by default, sorry, username by default is admin, and password by default is secret, which is not so secret, but that's a training instance to be terminated in an hour. So I will be fine with that. I'm logged in, and I will not change the password. Usually it asks to change password. Okay, not this time. Good. That's fine. And I have to go to my dashboards we installed recently. Analytics dashboard, DSC cluster or DSC cluster condensed. Let me watch this one. Okay, it has not yet connection with Prometheus, which is weird, but it should. Okay, data sources. Let me check the data source. No, I don't want to save my changes. I want to check the data source. So yes, HTTP Prometheus operated 1990. This data source looks good to me. And I want to test it again. Data source is working. Okay, that looks better. And we go to my dashboards again. That's very weird. Okay, I will try another dashboard, but well, that should work in general. DC cluster. So that looks better. Yes. So no more issues, no more error warnings, and finally we have some situation here, and we could have plenty of things here. We could have here some coordinator metrics, cluster overview with some specific messages, how many nodes up, how many nodes down, if any compactions happening. If you will maintain Cassandra, you are going to be a very good friend to the compactions. It's a very important process. How many requests we have? Well, basically no requests. We don't have so many, but we have some clients connected. Mostly that's going to be management API. And we have had some writes recently, and we have some write latency, which is going to be for, let me increase this part a little bit. Yes. Okay. So we can see like, it's too small. I will try to make it bigger maybe. Okay, that looks better. So we can see what's the write latency for the percentile 75, 90, 95. Could you please show it to me? Perfect. And in the most of the cases for P95, it's 7 milliseconds. And for P99, it's 13 milliseconds. And that's pretty interesting. So we see a lot of things at this. Well, this node is obviously not supposed to run 3 nodes data stacks enterprise cluster. You need some more powerful machines for that, not a training node. But it looks better, and we can see coordinator read latency. So a lot of information to consider. How our read works, we can see cluster to reads, and so on and so forth, and very many important information available for you. And my job here is done, and I have one very last words to say. You will have to do well, I hope you did step 0 already. Finish step 1, which is not ready, and do step 2 on your own. And then don't forget, practice, experiment, play with your training files, change them and see how it works, because that's how education and learning and self-learning works. Don't afraid to make experiments on the training nodes, then your production will be in safe, and your production will be double in safe because of knowledgeable you. Don't be afraid to run experiments on your training nodes. If it's dead, well, then it's dead. We dispose them anyway in one day. And very last phrase, what we do now. Last few words. First one. Quick survey. I was speaking for 3 hours, a little bit more even, and now I want you to speak a little bit. Ah, come on, Menti. You make me sick. Okay, Menti moves on. That's something. How likely is that what you would recommend this workshop to a friend or a colleague? Not likely at all on the left, extremely likely on the right, and I want to see the results. So, while you are answering, I want to say what I was speaking today, but this workshop is a result of the work of many people. And I want to name first Cedric Lundberg, who created the original idea. I want to name Bettina Swinnerton, who made really a lot to make it smooth experience for everyone, and by some technical occasion was not able to join us today on the screen, which is very sad, but okay, next workshop we do a lot of them. And many others, Jack Fryer, community manager, David Gilardi, Eric Ramirez, and all the developer relations team. We speak to you, so feel free to contact us with your feedback. Thank you so much for your warm responses. How easy it was to get help during the workshop? Extremely easy, one voice, very easy, somewhat easy, not very easy. Okay, I'm sorry. I want your attendee experience to be the best of the best. Not easy at all. It looks like we did something wrong, or maybe you guys were on Twitch, because we don't answer questions at Twitch. Our main thing was that the Zoom chat, Zoom questions and answers, and YouTube chat. And maybe there were simply too much of you and not enough of our employees in the chat. But you know what? I have a very good secret for you to share in just 30 seconds, so stay tuned. Okay, we are done with main team, and then last thing. So, what's next? 5 places to go. First, academy.datastacks.com. Academy.datastacks.com provides free massive courses for Cassandra and other technologies you may be very interested in, and that's for free, so you don't pay for attending these courses. I see some people were not satisfied on how we are answering questions in chat, and well, yes, it's not convenient to answer questions in chat when you have few hundreds of attendees. So we have a much better place for you. Go to the community.datastacks.com. There are Bettina Swinnerton, Eric Ramirez, and many others of DataStax and friends and experts in general in the field to answer your questions. We consider community.datastacks.com as Cassandra related Stack Overflow and similar technologies related Stack Overflow. Subscribe. We are on YouTube, DataStax Devs, Twitch, well, secondary backup channel, and Twitter, of course. Now, all the slides, all this code, all the required things to do this workshop at the github.com, DataStax Academy, KubeCon, Cassandra workshop. And there is a very interesting talk was done at our conference, Accelerate, why tomorrow Cassandra deployments will be on Kubernetes. If you are interested in Kubernetes and distributed databases handling petabytes and petabytes of your data with ease within milliseconds, that's a very good thing to watch. This one is very interesting. And one more thing, Cassandra, the definitive guide, very good book, written by Jeff Carpenter and Eben Hewitt. It's available for free as an electronic edition at the datastacks.com resources, ebook, O'Reilly Cassandra Definitive Guide. Big thanks to our friends from O'Reilly and big thanks to After. It's a really good book if you want to get deep into the Cassandra. And we did survey, and thank you. You are great, and I hope this day make you better developer or operations or whatever you are doing. Thank you so much for being with us. Workshop is over, but we are here still for you to answer your questions at the community.datastacks.com. Thank you.